Hello, my name is Lauren Pryor, and today I'll be covering two of the most important fundamental topics that we've covered in the first few weeks of Math 172 for my advanced learning project. And the first one that I'm going to talk about is the Pythagorean theorem. And Pythagorean theorem is defined as a squared plus b squared, which is equal to c squared. And in this formula, a is equal to the side length, to this side. B is equal to the other side length, and C is equal to the hypotenuse. Pythagorean theorem can be explained with a picture, such as this one over here. And I can explain this further as we attempt the first example over here. So, to tackle this first example right here, we're going to try to find C, which is the hypotenuse. Pythagorean theorem is used to find missing side lengths of triangles. So just to start for this one, we're going to take this formula and apply it. So 8 is going to be B, 6 is going to be A, and X is equal to C. Now to write this into this formula, we're going to have A squared, not A squared, we're going to have 6 squared plus 8 squared is equal to c squared or x squared. Now 6 times 6 is going to be 36, 8 times 8 is going to be 64, and that is going to be equal to c squared or 100. Now, to find, so 100 is equal to c squared, not c, which is what we're looking for here. So in order to get x, we're going to need to take the square, we're going to need to take the inverse of this. So we're going to need to do the square root. So the square root of 100 is equal to the square root of c squared. So that is going to be 10. C is going to be equal to 10. Now I'd also like to explain how this applies. So we're going to sub in those values into this picture right here just to explain it a little better. These are supposed to be squares. These are poorly drawn squares. So we're going to have 6, 8, and 10. Now because these are squares, the side lengths are going to be the same on the length and the width. So the area of this is going to be 100. And for this, we're going to do the same thing, 6 times 6, which is going to be 36. And then we're going to have the same thing for this square, 8 times 8, which is going to be 64. Do these numbers maybe look a little familiar? Well, that's how the Pythagorean theorem works. All right, and now we're going to talk about the second. To do the same thing, we're going to take a squared plus, this is equal to b, we're going to take 8 squared, sub that in, and then that is going to be equal to our c value squared. Now, this is going to equal a squared plus, we could simplify this, plus 64, which is equal to 144. And now to simplify this further, we can take 64 away from 144, which is going to leave us with 80. Now, to simplify this, we're going to have to take the square root of both sides. And the 80 is not a perfect square, so we're going to have to maybe divide this up into some multiples. And I think I'm going to use 16 and 5 here, because 16 is a perfect square that we can use. So the square root of 16 is going to be 4, and then 5 is not a perfect square, so that will remain under the radical. And a is equal to 4 square root 5. Now the last example that I'm going to be talking about is an application question. So two hikers are staying in a cabin in the woods. One of the hikers decides to head south 2.8 miles, and the other hiker heads west, going 3.1 miles. And what is the distance between the two hikers now. So we're gonna need our compass for this. So for this one, so now we have their cabin, and one of them headed south 2.8 miles. So south's gonna be down, and that's gonna be 2.8 miles. And then one of them headed west 3.1. So west is going to be towards me. So we're gonna draw a line over here, going 3.1 miles. And what is the distance between these two hikers now? So we're going to connect these just to make a triangle. So now we're looking for C here, the hypotenuse. So now we're going to use this formula again. 3.1 squared plus 2.8 squared is equal to C squared. I'm going to break my calculator out for this one. So here we have 3.1 squared is going to be equal to 9.61 plus 2.8 squared is going to be 7.84, which is going to be equal to C squared. So now we're going to add these together, and I got 17.45 is equal to C squared. So now all I have to do is take the square root of both sides. And that's going to be approximately 4.17. The next topic that I'm going to be covering is coterminal angles. And every angle will have a coterminal angle. And so I'm going to start with just drawing out our 4 quadrants. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So let's say that we have an angle of 30 degrees. Let's say that this angle is precisely 30 degrees. The coterminal angle, the positive coterminal angle is, so this right here is going to be our initial side, and this is going to be our terminal side. So the positive coterminal angle is going to be the other side of this, basically. So on the coterminal angle, we're going to start at 30 degrees and take it all the way around back. Back to the initial side. So this angle right here, this very obtuse angle, is going to be equal to 360 degrees minus the 30 degrees, which is going to be equal to 330 degrees. And that is going to be only one of the coterminal angles of 30 degrees. Now, coterminal angles will also apply if you are subtracting 360 degrees or adding 360 degrees. It will come back to the same place on the graph. So another example for this would be 30 degrees plus 360, which will be 390 degrees. That will also be a positive angle. Now, if you wanted to do a negative angle, you could do 30 degrees minus 360 degrees, which is going to give you a negative 390 degrees. But all of these are coterminal to 30. Now, let's show another example. Now, another example, I'll use 210 degrees. So here is the initial side. Then we're going to come all the way around to 210 for the terminal side. And this obtuse angle is going to be 210 degrees. Now the coterminal angle is going to be the degrees from this terminal side back to the initial side. We're going to follow that over here, and this angle is going to be 150 degrees. Both of these should always equal 360. Another example with 210 would be to add or subtract 360 degrees. And those would also be coterminal, so it's going to be negative 150. And then this one right here should be a positive 570 degrees. And all 570 positive, negative 150, and a positive 150, all of these are going to be coterminal to 210 degrees.